All right, Gianni, this one's for you. So let's go. We're departing from separable differential equations, and we'll figure out how to solve one type. And as I told you, I took a whole year of college, or whole class, half a year of college, on these things, and it was, like I said, the first hour of class covered separable ones. So there's tons of other kinds, and you're going to see one other kind, and that's as far as we're going to go. At the high school level, that's great. So let's go ahead and see how that works. Name this. A pretty cool.
Thank you, Gianni.
Homogeneous. Can anyone spell homogeneous for me?
What's the
maybe.
word?
Homogeneous.
H-O.
Wait a minute, let me get my chalk. All
I feel
right.
like there's an A in it.
H-O-M-O-G-E-N-O-U-S.
And I think
It's kinda
there's
leave it to Aaron.
in this
Oh,
one,
E-O-U-S.
I don't know if
Right.
that's the
Yeah, that
word.
looks right.
I don't know if that's the word for homogeneous milk. I think it might not have that extra E in homogeneous. It doesn't sound like it, but this one is spelled this way and is also pronounced homogeneous. I have also heard it pronounced homogeneous. So,
That's
I
what
don't
I
know.
think when I see
So-
words like that.
really? All right. So in milk, do you know what homogenized milk looks like?
Doesn't sound like it looks good.
It's like the fat is distributed evenly.
Oh.
So like if it's
Milk
all,
is so
if it's
good.
not
What are you talking
homogenated, all the fat goes to the top. And you have to stir it. You have to stir it. So, all right. Sorry to upset you with these
Don't say it again. I'm gonna throw up.
All right.
What are you doing?
Throw it on the camera.
All right. So our equations are going to be more appealing. All right. Let's see. Homogeneous differential equations is their title. What's it mean to be homogeneous when you're a differential equation? Here is the characteristic of homogeneous, so you know. The variable, when you do a variable substitution, these are inseparable as they stand. But when it's homogeneous, then you can make a substitution. We'll call it a variable substitution. Is it showing up all right?
Just ask me a question.
What?
Is it showing up already?
Oh yeah, it's good.
Make a variable substitution and it will be separable. It will separate.
I must spell
All right.
Big Mac.
All right, so there we go.
All right.
All right, the first example, and what we're going to do with these is we're going to actually, you know how these have derivatives in them, so dy dx. We're going to rewrite the problem and so that it has y over x in it. So write it down, it won't mean anything until we do one. So we're going to rewrite our homogeneous differential equation so that it is a function of y over x. When we do that, they will separate out. So none of that will mean much until you see a couple of them. So I'm going to start over here. So here's our first one.
Oh, Gianni, check out the new chain.
Yeah.
It's holiday edition.
Oh yeah, that's
It's
cute.
the new chain of Shane.
I didn't see that one.
Chamberlain.
Okay. dy dx equals
Sorry for the disruption.
x squared plus 3y squared over 2xy. That's our first one. I'm only going to show you one and ask you to do 4. So as many as you can get done in the classroom where I'm here to guide you will be to your benefit. All right. So is this separable? Can we get all the x's and dx's on one side and all the y's and dy's on the other as it stands here? You can try with this one and it will not separate because some x is always going to be stuck to some y and you can't get it apart. So if I had tons of time, I would have sent you to the board. I wouldn't have told you this was a homogeneous differential equation
would've been
that was
cruel.
inseparable. I would have said, separate this way. You guys would have moved things this way, that way, divide and multiply, and it never would have separated. So we're just going to skip to that point. Now this is what is in your thoughts. I have to rewrite this equation. Are you timing it?
Yes, it's 5:11.
Okay, let's cut it off at 10 or 12, all right?
All right.
Although the ones that we did yesterday at 15 did load very well, so it doesn't matter. But we'll probably need 2. All right, Morgan.
It didn't make it.
Good. You don't know what need to know what that was. Yeah. All right. This is what's in your thoughts. I'm going to rewrite this equation somehow so it has these floating in it. It can be y over x. It can be y squared over x squared. It can be y cubed over x cubed. But I want y over x. So, algebraically, what I do is I look for the largest power of y, and I want that on the top, and I'm going to use this form, the y squared over x squared. I'm going to develop that by multiplying the top by 1 over x squared, and the bottom by 1 over x squared, which does not change the value, it's a big fat 1. So, when I multiply the top and the bottom by this, I'm going to create a lot of these y over x expressions, and that's why I'm doing it. It always works with these kind, so. Brendan.
Sorry.
All right, dy dx equals. All right, Brendan, tell me what happens when I multiply each of these by 1 over x squared.
1
Very good.
plus 3y squared over x squared.
Right, and I'll write it like this. Are you comfortable with that?
Yes.
All right, that's the same thing.
Oh, yeah.
And on the bottom, then Brendan, we've got this times that.
2y over x.
All right, you see how I created quite a few of my y over x buddies? All right, good. All right, so now this, I gave you a clue that we're going to make a variable substitution. So the variable is going to be v for variable. We're going to say all the y over x's are going to be called v. This is always the substitution that you're going to need. So you might put a little star or an exclamation point or something like that. That this is always going to be the variable substitution in these kind. So when I do that, first of all, I hit dy dx, but I have to use this substitution, so I'll make a little box. So I can't just put in dy dx anymore because I'm substituting this mess everywhere. So what is y if v equals y over x? So Erin, solve that for y. What's y equal?
Y over V. Oh no, it's not for Y. Sorry. VX.
Dx. All right. And
Oh
now,
no, sorry.
Morgan, help me with this part. I'm stuck on the chain. So y dy dx is the derivative of y. So I can't. When I'm rewriting this, I have to know that I have to take the derivative. So what's dy dx? This is 2 variables now. So it's the first times the derivative of the second, or
right.
however else
Okay.
you do that.
So, oh yeah, because at first I thought v was a constant.
No, it
Okay.
is a variable substitution. So this is, it's not a L, it's not a C, it's a V.
So it ends up just being v plus x, right?
No, I think there's something else involved. So you said the first times the derivative of the second,
So v times 1
V, right, and then plus the second,
times the derivative of the first.
and the derivative of the first is what we need to know. Because we know what x's derivative was 1, but we can't say that the derivative of v is 1. We have to call it dv dx.
Oh,
All right,
jeez.
so that was pretty tricky, wasn't it? Very,
Yeah.
very mean. Can you see that? It's just squished in my box. Is it showing up? V plus x dv dx. So
Got it.
that's going to go in for dy dx. So v plus x dv dx equals 1 plus 3v squared over 2v, because that's why I picked v, to get rid of these y over x guys. All right, do you follow that? I'll let you observe that and ponder it. Do you see any problems? Jonathan, do you see what I'm doing? All right, everywhere there's a y over x, I put in a v. Here's one, here's one. And this came from dy dx. If I'm making this substitution, I have to be consistent. So I had to solve this for y and find the dy dx with the product rule. All right, so now, is this separable?
Yeah.
Yes.
It is, it's separable. So go ahead and separate it. I want all the b's and their business on one side, and all the x's and their business on the other. It's not that bad. Go ahead and
Wait.
try to get one's on one side and one's on the other. Then I'll jump in.
Miss Powell's home, it's 11.
Okay, why don't you shut it down while you're trying that. We'll be back on part 2.